Hi students, in this video let us discuss Amines Diazonium salts JEE Main 2021 March session. Okay, so in a previous video I discussed February questions, so that also you can see. I am sharing the link in the description. So this one is the first question. It is a diazotization of the aniline. Okay, so here in this one, see, the first one is the diazotization of the aniline. Okay, so here the diazonium chloride is formed. The X is benzene diazonium chloride, pH and 2 plus Cl minus. This one actually on heating with water, just you will get the phenol. So the option is third one. Okay, that's it. So next, which of the following reaction does not involve Hoffman bromide degradation? Okay, so what is actually Hoffman bromide degradation? So that is a conversion of the amides into amines. There is a conversion of the amides into amines by treating with bromine along with the alkali. Okay, that amide is converted to amine. Okay, so here in this case, generally it is called the degradation reaction because we can see there is a one carbon less in the product from the reactant. So this is the amide group here, CO. That means the CONH2 amide is converted to NH2 group. Here we can see there is a Hoffman bromide degradation reaction in this case. Now here this cyanide on hydrolysis in the presence of the alkali medium, it is converted to CONH2, and now this one on Hoffman bromide degradation reaction we can see that aniline CONH2 converted to NH2. So here in this reaction also we can see Hoffman bromide degradation. Okay, now here in this one the bromine NaOH H plus. Okay, it's nothing but a Hoffman, that means it is a haloform reaction. Okay, this is a haloform reaction. By the haloform reaction, here the product in the first step is acid. Here CH2C double bond O. Here ONA and plus CHBr3. Okay, that is a haloform reaction. Now here this one heating with ammonia. Okay, this one heating with ammonia, so generally here it produces CH2C double bond O, here NH2. Okay, that carboxylic acid is converted to amide. Now here this amide on reaction with the lithium aluminum hydride, this CONH2 is reduced to the CH2NH2. Okay, CH2 and CH2NH2. That means here in this case we could not see the Hoffman bromide degradation reaction. So just here first one is the haloform reaction. Okay, first one is the haloform reaction. Okay, so the very interesting point is the bromine NaOH on the amides Hoffman bromide degradation reaction, that is, and bromine NaOH on the methyl ketones haloform reaction. Okay, so that is the difference. Now here this acid halides on reaction with the ammonia and NaOH. This acid halide initially converted to amide. Okay, this acid halide is converted to amide by reacting with ammonia. Okay, this means here this is the ammonia good nucleophile attacks on the this carbonyl carbon, and here leaving out the Cl minus, and also deprotonation from the ammonia. As a result, we'll get the amide. Now here this amide on reaction with the bromine and NaOH, again this benzamide converted to aniline. Okay, this one also involves the Hoffman bromide degradation reaction. Okay, so in this case here this ammonia nucleophile attacking on the carbonyl carbon, that means here carbon of the CO group, here O minus, here NH3 plus, and this is the Cl. Okay, next here reformation of the pi bond and leaving of the Cl minus. So as a result we will get the C double bond O, here NH3 plus actually. Okay, so from this NH3 plus Here H plus also removed. So as a result, we'll get the benjamide. Okay. Now here this benjamide can be involved in a Hoffman bromide degradation. Only the primary amides can be involved in a Hoffman bromide degradation, converted to primary amides. Okay, that's it. So here finally the answer is 3. Okay, in this reaction only Hoffman bromide degradation is not involved. Next, ammonolysis of alkali halides followed by the treatment with NaOH solution can be used to prepare primary, secondary, tertiary amines. The purpose of NaOH in this reaction to remove the acidic impurities. Actually, here in this case, ammonolysis of alkali halides means I am taking for suppose methyl iodide. This methyl iodide on reaction with ammonia, there is nothing but ammonolysis. So here in this one, this ammonia nucleophile and leaving off this I minus. So as a result, CH3 and this one hydrogen, this hydrogen, this hydrogen here plus charge. Now here this one I minus. Okay, remove the H plus. So here as a result, this primary amine is formed, and here the product is HI. Okay, the side product is a HI. Of course, here in this case, again this HI can form this cation and anion. That means here, as a result of this reaction, here this salt will be formed. NH3 plus and I minus salt is formed. Okay, unless HI is removed. So here that's why we should remove this HI by adding with the NaOH. Okay. So and that HI is acidic in nature, NaOH is a base. So as a result of the acid-base reaction, so that HI acid impurities are removed in a ammonolysis of alkali halides. That's it. So answer is 3 actually. Okay, that's it. So in the place of the NaOH, generally we can use aqueous sodium bicarbonate. Okay, aqueous sodium bicarbonate means it has a solution of the NaOH and C2O3. That means here that aqueous sodium bicarbonate has a basic nature, because NaOH is a strong base, H2CO3 is a weaker acid. Okay, so next here, which of the following is the least basic compound? So here you see this one, the least basic. That means generally here the base is a good electron donor. Okay, that means electron donor. Okay, the species which is a good electron donor is a strong base. Okay, so first of all, in a first option, you can see this one. CH3C double bond O. Here N. This one. Yeah, this is a H and this one is a C2H5. Okay, that means it is a amide actually. And next in second case, triethylamine, and here diethylamine. Okay, and this is also amide. You see this one in the second case, 3 ethyl groups are there. Okay, triethylamine. So next here in third case, CH3C double bond O, here NHC double bond O, CH3. Okay, you see in this case, this lone pair of electrons are involved in a resonance with the CO group, as well as this lone pair of electrons are involved in a resonance with the CO group. That means here these electrons are more involved in a delocalization. Okay, with the 2 CO groups. Here these electrons are involved in a delocalization with only one keto group. But here in this case, these electrons are not involved in resonance, but here ethyl groups are the donating groups, increase the electron density of the nitrogen. And here in the fourth option, triethylamine. Okay, sorry, diethylamine. That is nothing but secondary amine. So here in this case, actually, 2 ethyl groups are the donating groups. Here 3 ethyl groups are the donating groups. So they are strong bases actually. But in this case, these electrons are not in a delocalization. So these compounds have less tendency to donate the electrons. Now here, in this case more extent of the resonance for this lone pair of electrons. So it is a weak electron donor. That's why ultimately it is a weaker base. Okay. So the lone pair of if the lone pair of electrons are involved in a resonance, that those compounds are the weaker bases because those compounds have a less tendency to donate the lone pair of electrons to the acid. Now you see this one reaction of the Grignard reagent with the cyanide. Here one equivalent is given. So generally here the cyanides, okay, C triple bond N, this phenyl magnesium bromide, I think it is. So pH MgBr. So pH minus here, Mg plus 2, here MgBr minus 1. So pH minus attacks on this carbon. Okay. So here C double bond N, this one MgBr, the positive part is coordinated with the N minus, and here pH minus is bonding with the C plus. Now this one on hydrolysis, okay, that is breaking into carbon compound. Here two hydrogens. So as a result here C double bond O, this one pH, that means ketone will be the product. Okay. So here in this case yeah, this fourth one is the correct answer. Okay, that's it. Now for bromide degradation of benzamide gives a product. So what is the benzamide actually? So if benzene is attached to the C1H2, that is a benzamide. So this benzamide in Hoffman bromide degradation, okay, that is converted to aniline, pH and H2. Okay. So now here, which that means it is a which upon heating with the chloroform and NaOH, okay, so it gives a product B. That means it is the phenyl isocyanide. It is a carboyl-amine reaction or isocyanide test actually. So primary amines can give the isocyanide test. That means your primary amines on reaction with the alcoholic NaOH along with the chloroform, you will get the foul smelling compound, that is the isocyanide. It is a reaction for the identification of the primary amines, either aliphatic amines and aromatic amines. Okay. So in the previous video, I have discussed the mechanism also, so we can see. So here in this case, the benzamide, the product A is this one, and product B is this one. That aniline is converted to phenyl isocyanide. Okay. So which of the following reaction is example of the ammonolysis? Okay. So here in this case, generally ammonolysis means alkyl halides reaction with ammonia. Those are converted into amines. So option 4 is a ammonolysis reaction. It is an acid-base reaction. Okay. Option 3 is an acid-base reaction. Next year it is a reduction reaction because cyanides are converted to amines. Now here in this case, it is just a acid halides reaction with the amines. We will get the amines. Okay. So alkyl halides on reaction with ammonia, you will get the amines. That is nothing but ammonolysis. Okay. During ammonolysis, amines are the products. Yeah, it is a one numerically based question in the above reaction. 3.9 grams of benzene on nitration gives a 4.92 grams of nitrobenzene. Okay. So actually here 1 mole of the benzene, okay, so here 1 mole of the benzene gives a 1 mole of the nitrobenzene. Okay, that means in this case 78 grams of benzene gives a 123 grams of nitrobenzene. Now here, so actually here, if you take a 3.9 grams of benzene, then what is the actual product of that nitrobenzene? Equals to 123 into 3.9 by 78, that equals to 6.15 grams. Okay. So if you take 3.9 grams, so you should get the 6.15 grams of the nitrobenzene. But actually we got during this reaction 4.92 grams of nitrobenzene. So here the percentage of yield is nothing but 4. This one 9 by 6.15 into 100. Okay, that equals to nearly 79 point something 8. So that is round off to the 80. So answer is additive for this one. Okay, that's it. So next, primary, secondary, tertiary amines can be separated by para-toluene sulfonyl chloride. Actually, here in a textbook, it is a given the benzene sulfonyl chloride is useful for the separation of the primary, secondary, tertiary amines. In previous video, I discussed detailed reactions which are involved in this process. Okay, so in place of the benzene sulfonyl chloride, also known as a Innsberg reagent. Innsberg reagent. Okay. So instead of this benzene sulfonyl chloride, we can use the para-toluene sulfonyl chloride. Okay. That means here SO2 Cl, this one CH3, para-toluene sulfonyl chloride. Okay. So answer is A actually. Okay. So chloroform KOH is not used for the separation. Okay. So just here it is used for the identification of the primary amines. Gives a isocyanates poor smelling compound. And benzene sulfonic acid is not used, and acetylamide also not used. So next here this compound actually, okay, it is containing two nitrogens and Cl. This compound on heating with ethyl alcohol, that is converted to anisole, and here N2. Okay, so generally here we know the one reaction, that is benzene diazonium chloride, okay, N2 plus and Cl minus, on heating with ethyl alcohol, benzene, and this ethyl alcohol is oxidized to the aldehyde plus N2 plus HCl. Okay, so in this case CH3CH2OH, okay, ethyl alcohol is a reducing agent actually. Okay, so here this benzene diazonium chloride is reduced to benzene. So during this reaction, ethyl alcohol acting as a reducing agent, and it is oxidized to the aldehydes. Okay, so here this one actually a reduction of the benzene diazonium chloride. So in this case, yeah, actually here this one satisfy the given reaction. Okay, so here 7 carbons are there, here 7 hydrogens are there, and next here one oxygen, one chlorine. So this one on reaction with the heating with ethyl alcohol, this group is totally removed. That gives us simply anisole, and this ethyl alcohol is converted to acetaldehyde and HCl. Okay, that's it. So next here the first step is a diazotization. Okay, so product is a pH N2 plus actually. Okay, Cl minus. Of course, this one attacks on the para position. As a result, you will get the azo di. Okay, that means here this one actually. Here you can say this one is the answer. Okay, so here the first formation of the diazonium chloride, and that is involved in a coupling reaction with the N dimethyl N. Okay, so that's it. So actually it is a para-directing group. So of course ortho-directing group also, but here due to bulky nature of this nitrogen, methyl and methyl, of course this bulky size of the electrophile that mostly attacks at the para position. Okay, so that's why this is the exact answer. Okay, in a reaction of hypobromite with the amide, the carbon is lost as actually it is nothing but Hoffman bromide degradation. So here C double bond O NH2. Okay, so actually we are using Br2NaOH. Okay, Br2NaOH. Okay, it can be nothing but NaOBr. So during this reaction, this amide is converted to amine, and the side product is Na2CO3. Okay, Na2CO3. Yeah, here in this case, this CO group actually, okay, this CO group is converted into carbonate actually. Okay, that's why here this is given a reaction of hypobromite with amide. The carbonyl carbon is lost as carbonate. Okay, so the final answer is CO3 minus 2. Yeah, an organic compound A and treatment with benzene sulfonyl chloride. So you see this one, organic compound A and treatment with benzene sulfonyl chloride, SO2Cl, gives a compound B, and this B is soluble in a dilute NaOH. Okay, that means it is a primary amine. Okay, total detailed reactions are already discussed in a previous video. Okay, that means your February JEE main 2021 questions. Okay, so I am sharing that link, you can see the video. So benzene sulfonyl chloride gives a compound B is soluble in dilute NaOH. It means it is a primary amine. So ultimately the answer is 4. Yeah, again here this one also repeated 3 4 times this year 2021. Okay, so in this case ortho percentage just 2 percentage, meta percentage 47 percentage, and this one is a 48 percentage, sorry, this one is a 51 percentage actually. Okay, 51 percentage, and yeah, it is a 47 percentage, and it is a 2 percentage. So during this in this reaction, generally we got a more meta product than the ortho, because even it is a NH2 is ortho para directing group, your ortho percent is very less than the meta, because due to presence of this H2SO4 acid, this aniline is converted into, okay, this aniline is converted into NH3 plus anilinium ion. Okay, this anilinium ion is a very strong minus I group, that is strong withdrawing group. Okay, so deactivate the benzene ring. All deactivating groups are the meta directing groups. That's why we can see 47% of the meta product. So those are the March JEE Main 2021 questions from the amines and diazonosols. Please like the video,